Achha, now we did the mechanism part, I think. Mechanism part, and I told you that we did some questions on this as well, right? That I told you that you can figure out uh, the if you have two reactants, right? Okay, this is what we did. If you have two reactants in a reaction, then the reaction is divided into steps. You have step one, step two. So if one of the steps is a slow step, then the rate of the reaction depends on your slow step, right? Increasing the speed of the fast step will have no effect on the overall speed of the reaction. So if OH ions, one of the reactants, OH ion, if it's in the fast step, then it's zero order. That means you increase the concentration of OH ions, the overall speed does not increase by a lot. Okay, but if you increase the concentration of your halogenoalkane over here, so in this case, the reaction will speed up. So it all depends on the slow step. So the so so my rate equation in this case is going to be that the rate of the reaction depends on the halogenoalkane concentration and its power 1, and it does not depend on the OHN concentration, so it's power 0. So that automatically removes the so it automatically removes uh, your OHN concentration from this equation. Okay, Varda, is this clear?
Yeah, it's clear.
So I'm going to move on now. Okay, there's a third way of finding order. Now this over here is so this one over here is the experimental method. So bas ek second, let me open the. I need a. So this one is the easiest. They will do different experiments, and using those different experiments, you can figure out. Just 1 second. Where's the? So let me just take this one for example. So for example, I've got two reactants over here, and what I have over here is that I've got H2O2 and H plus 1. These are my two reactants, right? So different concentrations are used. Like if in the first experiment, the first one is experiment number 1, there's a concentration of H2O2, there's a certain concentration of H plus 1, and there's a rate calculated using this concentration. The reaction has a particular speed. Then you do experiment number 2, right? You increase the H2O2 concentration. The H plus 1 concentration remains kind of the same, and the rate increases, right? So what we're going to do is we're going to try and compare the two experiments. Okay, we're going to try and compare the two experiments, experiments 1 and experiment 2. And what has happened in experiment 1 and experiment 2 is that the H2O2 concentration, it increases. Can you tell me by what factor does it increase? But if you go from 5 to 7, by what percentage factor does it increase? What क्या percentage इसकी?
Is it times by 1.4?
Because that's times 1.4, right?
140?
Because it's 1.4, right? Your H plus one is not increasing, but by increasing the H2O2 concentration, by what factor does the rate increase? That's also 1.4 times, right? So
Yep.
that means what's the relationship between hydrogen peroxide concentration and the rate? Is it order 1, 0, or 2? What is it?
Order 1.
Yeah, that's order 1, directly proportional, right? So if you compare, this is how you can write that if you compare experiments 1 and 2, the H2O2 concentration increases 1.4 times and your rate also increases 1.4 times. So hence this is order with respect to H2O2's concentration is 1. So now we need to find the. So basically, what we need to do is we need to like if I want to compare H2O2 with rate and find the relationship, I need to keep the concentration of H plus one constant, right? So let's do the same thing now, but let's try and find the order with respect to H plus one. अब इसका बताओ कि which experiment should I compare?
2 and 3.
No, but if I compare 2 and 3, I need to, the concentration of H plus 1 should change, while the concentrate and the rate should change accordingly, whatever happens to rate. But I need to keep H2O2 constant, right? Is that clear?
Okay.
But in this case, I won't be able to keep H2O2 constant because H2O2 is changing in every experiment, right? So now I've got a problem. Like I can't do the same for H plus 1, what I did for H2O2. Is that clear?
Yep.
So how are we going to find the order with respect to H plus 1? So my rate equation is at the moment this. That rate depends on what? It depends on H2O2. It's order 1 with respect to H2O2. And it depends on H plus 1, but I have no idea how it depends on H plus 1. So that's X. So I have no idea how it depends on H plus 1. Now the other thing is, you have no idea how it depends on H plus 1. So the way I'm going to do is I'm going to try and solve it simultaneously. Let's say I'm going to compare experiments 2 and 3. Yeah, let's say I compare experiments 2 and 3. But I've got a problem. I won't be able to compare. So I'm going to try and solve it simultaneously because there's one unknown, which is X. I said now what I can do is I can get rid of the proportionality sign. There's going to be a constant K over here. I mean, you get rid of proportionality, you get a constant. This constant is known as this constant is known as the rate constant. Is that clear that you got a constant, right? Is that clear?
Yeah, that's clear.
So I'm going to plug in values for experiment number 2 into my rate equation. So if I plug in experiment 2 values, it's going to be what, 1.4. That's rate. I don't know what K is. H2O2 concentration is 0.07. And that's power 1. And H plus 1 concentration is 0.05. And I don't know what the order is. So that's going to be taken as X, right? Now I can rearrange this and I can figure out the value of K, which is what K would become 1.4. It's going to be divided by 0.07 and 0.05 to the power x. Yeah, that's experiment number 2. And I can plug in values for experiment number 3 as well. Now, experiment number 3 is 1.8 is the rate. So I've got 0.09. Power is 1. I'm plugging in experiment 3 values. I've got 0.07. That's power x. I already know what k is. K is a constant, right? So I can take the k from the first one and put it over here. So it's going to become what? It's going to become 1.8 is equal to 1.4 divided by what? 0.07, 0.05 power x times 0.09 power 1, 0.07 power x. And we can now try and solve for x, right? So if I take the other things to the other side, so it's going to become 1.8. Can you try 0.07 divided by what? 1.4. And you've got 0.09. And on the other side, over 0.05x. Can you try and solve the left side?
It's 0.1.
It can't be 0.1.
No, it's not. I made a mistake. It's 1.
No, it can't be 1. See, it's basically 18 over 14, 7 over 9, right? It is 1, right? 1 second. This is coming out to be 2. 7 over 14 comes out to be 2. So it's actually 1. I think it's actually 1, right? So you're getting this as 1. And this is 1.4 to the power x, right? So what do you think x is?
Um, 0.
Use x is 0, right? So that means this entire working over here, that's x comes out to be eventually. It's going to eventually come out to be 0. Okay, but is the idea clear? How do you calculate order?
So you know how it says in the question, reduce the orders? So you need to find 3 different ones.
It's just two different orders. I mean, you
so
got
how
him.
do you know this?
Hmm?
So how would you know that you need to find 2?
It's you're going to find the order for H2O2 and you're going to find the order for H plus 1.
Okay, that makes sense.
Okay. So for H2O2, you're going to try and find an experiment where only H2O2 changes, the other one stays constant. And you're going to see the effect on the rate of the reaction, right? And for the other one, you're going to do the same. But if you're not able to do the same, then it's this. You try and solve it simultaneously. You plug into experiment values into the rate equation where you have partially found one order, not the other one. So we're gonna try and do some questions on this. ठीक है तो एक second. I said try doing this one. There are 2 reactants, right? NO and O2. Which experiments would you compare first if you want to find the order with respect to NO?
Is it 2 and 3?
For NO, you want NO to change. You want the other one to be constant.
Okay, so 1 and 3.
So 1 and 3, right? So what happens over here? It becomes, by what factor does it increase or decrease?
Is it times by a half?
Yeah, this is off. Um, your O2 concentration remains constant, so that's not a factor. What happens to the rate of the reaction? And, and the simple way to find out factor is you take this number divided by this number.
Yeah, so it's divided by 4.
So it's 1 by 4, right? So what order is this? Like you halve the constant. Yeah.
Is it 2?
So it's order 2, right? So it's you halve the concentration over there, it became 1/4, right? So that means your rate is basically proportional to the concentration of NO, but the order is 2, right? Now you got to do the same thing for O2. So which experiments will you compare?
1 and 2.
1 and 2, right? So, no, you can't compare 1 and 2. You want the other one to be constant. Now you want O2 to change. You want NO to be constant.
Okay, so 2 and 3.
So 2 and 3, right? So this is half again, right? This remains constant. What is this other factor? That's also half, right? So that means what is the relationship between rate and O2?
They're directly proportional.
So that's order 1, right? So that's your rate equation. You can put a K over here. Uh, they would sometimes ask you to actually calculate the value for K as well. I mean, over here, like this is the rate constant. So you can get rid of the proportionality sign, put a constant K. Once you have the rate equation, then you don't actually have to do an experiment. You can just plug in the concentrations. You can find the rate of the reaction, right? So, so once you have the complete equation, so where he's asking for the, uh, so he's asking you to calculate the rate constant K. Can you try and calculate the rate constant K? You can just plug in any experimental values, like the first one. Plug in the experiment number 1 value into this and find what K is, plus the unit of K as well.
I got K is 700.
700. You'll probably be right. What's the unit for this?
Um, I'm not too sure, but is it moles minus 1 dm minus 9?
I think you can take the units from here, right? It's what is the unit for rate? It's concentration change, it's mole per dm cube per second, right? I can take mole per dm cube as
Uh,
x. Uh, then it's mole per dm cube squared and mole per dm cube power 1. So it's going to be what? It's going to be x minus 2, s minus 1. That's k. That's mole minus 1 dm6.
I don't really understand how you did that.
This is what is the unit for NO concentration? That's mole per dm cube, right?
Yeah.
What's the unit for O2's concentration? That's also mole per dm cube, right? What's the unit for rate? That's mole per dm cube per second, right? I just took mole per dm cube as x, so I can. It's easier for me to simplify. So this is
Oh, okay.
mole per dm cube per second. This is k times mole per dm cube squared multiplied by mole per dm cube, right? So at the end, I just get x minus 2, s minus 1. So I plug in mole per dm cube into this and I get this thing. Okay. You clear?
Yeah.
So find, 1 second. Uh, Try this one. You got two reactants, right? So try and find, so try and find the orders with respect to both of them. Or it's gonna again you have to actually do the whole mathematical thing because like if you try to find the order of this one, I mean you'll be able to find the order of this one directly. I mean for this one, which experiment should I compare?
For the first one or the second one?
Second one, because you won't be able to find the first one directly.
Oh,
Because
okay.
I wouldn't be able to keep this constant, right?
Oh, yeah.
So we can leave the first one for the later part because we have to solve the whole equation thing, right? But we can find NHC's order initially. So which experiment should I compare for this one?
2 and 3.
Okay, so this is double, right? And that's 4 times, right? It's okay. This is order two, right? Find out for the first one, CLO minus one. So are you doing this one?
Yeah, I'm doing it.
Are you done?
Yeah, I'm done, but I don't think I got the right answer.
See, just a second. So rate right now is you don't know about 0 minus 1, right? There's a K. This is X. For NSC, we got order 2, right? You get
Yeah.
that? So I'm going to put, so I want to find 0 minus 1. So remember, 0 minus 1 must change, right? So I'm going to do experiment 1 and 2, right? So it's, so the first one, the rate is 0.256. And I said, with K, there's no proportionality. There's just, I said, so I've got K, zero point 0.2 to the power X and 0.1, that's squared, right? And what does that give me? K is 0.256 divided by what? 0.2x and 0.1. So the other one is experiment number 2. So that's what rate is 2.05 is equal to k times zero point 0.4 power x, and that's equal to 0.2 that's squared, right? So I'm gonna replace k. K is what? K is 0.256 divided by 0.2 to the power x and zero point 0.1 squared, right? So I'm going to take 0.256 to the other side. 0 0.1 squared. What is 0 0.1 squared? That's 0.01, right? So I'm going to take 0.2 squared to the other side as well. So can you tell me what do you get for this? The right side is 2 over x. I mean 0.4x over 0.2x, that's 2 over x. What is this side? What do you get for this?
So am I supposed to multiply the two fractions?
Yeah, these two, yeah. I mean this is half square. This is 1 over 4. This is 1 over 2 squared. So that's 1 over 4. What is this thing?
Um, 8.0078125.
So that's, I mean, this side is 8, right? So 1 over 4, that's what is that? That gives you 2, right?
Yep,
So it's basically 2. So 2 to the power x is equal to 2, right? So what is the value of x?
1.
Okay, so x comes out to be 1. You clear? Is this clear?
Yeah, it's clear.
Try and this one. Try doing this one. Find both orders. Okay, just one second. Let me find one which has 3. Just one second. Try doing this one. The 3 reactants. You have to find the order with respect to this, this, and this. 'Do the ones first where you can find them directly. And if there's anyone that's, तो पहले इसका बताओ BRO3 minus 1. Which experiments would you compare?
1 and 4.
ठीक है, so it doubles. What happens over here?
It doubles.
So the order is what?
1.
Yeah, this is order 1, right? So BRO3 is done. Now for BR minus 1, which experiments would you compare for BR minus 1?
One and 3.
Yes, 1 and 3. So what happens? What order is Br minus 1?
Is it order 2?
And why is it order 2?
Because that one's times by 4, the other one's times by 0.25.
This increases by 4. How is this 0.25? Like 1 and 3?
Oh, it's divided.
Yeah, but if you divide it, you divide this number by the top number, right? Can you try doing this again?
Okay. I got 4.
Yes. What's the order now?
But isn't the okay? Oh, okay, that makes sense. So it's order 1.
Yeah, this one is order 1 as well. So what about the last one, H plus 1? Which experiments would you compare?
One and 2.
Okay, so you don't actually need to do any math. You compare 1 and 2, so that's doubling, right? What happens over here?
Times by 4.
So that's order 2, right?
2. Yep.
Yeah, so you didn't need any math. If you had, like, if you had to do it, like, it would have been the same way. Like, you would have done rate is equal to k times BR03 minus 1. Its order you had known, that's 1. BR minus 1, its order was known. The last one, let's say the last one you did not know. So you would just plug in two experimental data values into this for H plus 1. Just ensure that H plus 1 changes and do it in exactly the same way. So you could have any number of reactants, but it's the same technique that's going to be used. Okay. Do you clear? Is this clear?
Yep, it's clear.
So I'll send you the worksheet and try and do questions in this. Okay. And
Okay.
but there's just very little left, so we'll do that tomorrow then.
Okay. So can you please send me the worksheet then?
I'll send you the worksheet right now.
Okay. Thank you.
Okay, take care. Love.
Okay, you too.